Okay, so we are now into chapter six. Chapter six is all about decimals. And the subtitle of chapter six is Rational and Irrational Numbers. We're going to talk about what that means. But to start, we're going to dive into just the meaning of decimals and lay a lot of foundational uh, topics, discussion about just all about decimals, the backgrounds, the modeling of them, things that you might not have considered before in this video. And I will note that we will be using some manipulatives here. There are printable copies in your Blackboard shelf, but there are 4 pages if you have the actual punch out ones. One looks like this, another looks like this, another looks like this, and the fourth one looks like this. And so they're all squares, decimal squares. Punch those out, and then they will, when you are done, be kept in, you can't see that when it zooms out like that, in this lovely little folder that says decimal squares, and you're going to have 9 of the tenths squares, uh, 19 of the hundredths squares, and 20 of those thousandths squares. So to get started, you might want to go punch those out uh, for use throughout this chapter. And so I'm probably not going to be using those to demonstrate. I have a few um, tiles or I guess screenshots that show the use of these. I might suggest that you use them as you do certain types of problems. And I also have some links, and those are included in Blackboard, to GeoGebra online manipulatives, which utilize the same sort of conceptual thinking that these manipulatives do. So let's go ahead and jump right into this. So as far as our overview and our terminology, we're going to start with a little spotlight on teaching and learning, which I always like to do whenever I can. You can see here some of the different terminology that we will use. Again, we're going to talk about how we model decimals. That's the theme, right, of this whole course. How do we take and get away from just an algorithmic step-by-step written approach to solving a problem to actually modeling it using something physical. We're going to talk about equality and inequality of decimals, look at some ways to examine those, and then talk about what a rational number is. This is going to be a fun section here where we look at terminating and infinite repeating decimals and how we actually can change a decimal into a fraction. We looked at the density of fractions earlier in the course. Now we're going to look at the density of rational numbers or decimals, and then talk about how we might approximate when we're working in the decimals. So a couple things regarding the spotlight on teaching and learning. The Common Core we've talked about. You can see here some of the expectations for students when they are in grades 4 and 5 and 6. Notice how it references ratio and percent as well. Concepts of ratio, rate, and proportion. Decimals are linked with these ideas. Rational numbers, decimals, fractions, percentages, ratios, they are all just interconnected. And when we teach these things, we have to teach them as the same idea, just representing different things. When students view mathematical concepts as disconnected, it's almost as if it takes up more space in their brain. Once we can link ideas together, mathematics becomes very compressible. Okay, once you start to see the connections to things, you'll notice that here, the National Council of Teachers of Mathematics recommends that programs should enable students to recognize and use connections among mathematical ideas. Here is one of these examples of a decimal square. And so I want you to think about modeling fractions, decimals, percentages. I know we haven't talked much about percentages yet, but we will. Think about how a square that's 10 by 10 might help you model these different ideas. In fact, I've got a question for you to consider before we get really started here. Looking at this, can you write a decimal number that describes the shaded portion of this square? Can you also show that as a percentage? And then can each of the numbers you found be read entirely off the diagram? Meaning there are conversion processes to go between fractions and decimals and percentages, but can we just get those ideas by looking at this picture rather than following rules for doing those conversions? Just take a moment and consider those questions and those ideas. And maybe come back to this even as we go through this particular video and really this entire chapter. So let's start with some terminology and some definitions. The word decimal actually comes from a Latin word. Many of our words in mathematics come from Latin words. Decem is the DECM, that is the Latin word, and it means 10. It means 10, which makes sense because we use a base 10 number system. We talked about that earlier in the course. So any number written in base 10 can really be called a decimal. But usually we're referring to numbers like 17.38 or 0.45. Usually we're referring to those as decimal numbers when they have a decimal point in them, right? When we see, where's my cursor? There it is. When we see a decimal point, that's what we usually think of when we're talking about a decimal number. If we're getting really technical, a number like this, where we have a whole number and a decimal part, we might call this thing a mixed decimal. Whoops, a mixed decimal, because it has a whole number component and a decimal component. Another thing I'll note here on the front end is that decimal numbers like 0.45 can be written with or without that leading zero. Often in here, you're going to see it without, but please note that that is acceptable to have either way. So when we write a decimal number like 7.08, what you'll see that is that the number of digits to the right of our decimal point, so these digits right here, those refer to the number of decimal places. So in 7.08, we would say that that has 2. There are 2 decimal places, the 0 and the 8. If we write 104.5, that is only going to have 1 decimal place. Another thing that's important to recognize is the positions of the digits to the left and right of our decimal point are place values that are related to powers of 10. And so let's take a look at what that means. Here is a little chart that demonstrates this idea of place values. Place values. And we talked about place values again earlier in the course when we talked about having a base 10 number system. And specifically, we were looking at the whole numbers to the left side of that decimal point. And what you'll see is that we've got 3 in the units position or the ones place, 7 in the tens place, 4 in the hundreds place, and 5 in the thousands place. Again, those are all based on powers of 10. This is 10 to the first. This is, I'm sorry, that is actually 10 to the 0. This is 10 to the first. This is 10 to the second. This is 10 to the third, right? 1,000, 100, 10, and then the units position. Once we move to the right of the decimal, now we are talking about the decimal places, the numbers in those decimal places, the 2, the 8, and the 6. So the 2 is in the tenths place. So the tenths place can be written as 10 to the negative 1. Notice how we are decreasing exponents. And when you get into the decimal places, your exponents actually become negative on those. The idea of a negative exponent, 10 to the negative first, means 1/10 or 0.1. So a negative exponent actually makes your number smaller. When we are in this next place, the 8th, that's in the hundredths place. And the hundredths is 10 to the negative 2 place value. And then the 6 is in the thousandths place. So that is 10 to the negative 3 place value. And so it's important for us to recognize the names of those place values so we can properly read our decimal numbers. And so that's what we're going to get into uh, momentarily. And so the first thing I'm going to ask you to do, again, as we go through this, is look at the numbers that I've shown here. And there are arrows pointing to certain digits. And what we're going to do is express the value of that digit that's indicated by the arrow as a fraction whose denominator is a power of 10. So we're going to really be looking at just the number that I have arrowed, indicated, and what's the value of that number. And so when we look at this, this 5 here, it's indicated in this first one, the value of that number is 5 over 100 because it's in that hundredths place. If we think about that chart that I just showed you up here, it's in that position right there. It's in the hundredths place. So take a moment and just do that same thing with those next two values. So in number 2, we have the number 9, right? We're looking at that 9. So that could be indicated as 9, and it's in the tenths, hundredths, thousandths place. So that is representative of 9 1,000ths. That's the value that that 9 represents. Here we have a 0, and it's in the tenths place. So this is saying we have 0 tenths. So why did I have you do this? Why did I have you do this exercise? Because, and again, we did this when we were talking about whole numbers. We looked at numbers in expanded form. So just like whole numbers, decimals can also be written in expanded form. Write this out for you. Expanded form. When we write a number in expanded form, we are looking at the exact value of each digit in the number. And so here's what that would look like for 473 decimal point 2865. So let's take a moment to just examine this. So the 4 is in the hundredths place. So it's 4 times 10 to the second, or 4 times 100. The 7 is in the tens place, so the value of that number is 7 times 10, or 70. The 3 is in the units place, or the ones place, so its value is 3 times 1, or just 3. And then we go into the decimal values. This first place is the tenths place, so it has a value of a tenth, and then there are 2 of them, so it's 2 times a tenth. Moving on, this is 8 times 100th. This is 6 times 1,000th, and this is 5 times 10,000ths. We can also then even do a little bit of those calculations, because this can be helpful as well. This 4 is worth 400 if you actually do the multiplication. Plus the 7 really has a value of 70. 3 has a value of 3. That 2 has a value of 2 tenths, or as a decimal, 0.2. The 8 has a value of 8 hundredths. The 6 has a value of 6 thousandths. Again, we're just kind of combining the number plus its place value, 5 10 thousandths. So that's this expanded form of the number. I have a couple links in your Blackboard shell, one of which is writing numbers in expanded form. And these take you to this site called GeoGebra. You may have remember this from, I think, either chapter 1 or chapter 2. We saw some links with this as well. And what this does is it just kind of works you through this. Play around with this. Let me zoom in so you can see this a little bit better. Right, we have this number 941.06, and as you just click on each number, it automatically fills the numbers in where they would go in this sum, right, in this expanded form. And then as you scroll the dial to the right, it goes through and it does those calculations. You can see this is 900 plus 40 plus 1 plus 0 tenths plus 600ths, kind of like I did for you earlier. And then if we take it one step further, it's also equal to 900 plus 40 plus 1 plus 0 plus 0.06. So then it restates them in those decimal forms. And then you can do a new number. I suggest you play with this because it helps you as you see those sort of unveil, as you pull that dial to the right, what the value of each one of those place values is. So just suggest that you play around with that. Now, another thing we have to be able to do is read numbers properly. And this is something that often gets done incorrectly. So I'm going to write a number here, and we're going to talk about how we would read this. So this number is 1208, then our decimal point, and then 0925. And I think what I actually do is I'm going to do a different one I'm going to come back to that one. Okay, I'm going to do a different one that's a little simpler first. I'm going to go 17.6. We're going to talk about how we would properly say that number. When you have a decimal number and you want to read it, you start by saying the number in front of the decimal point. You would read that just as it is. This is the number 17. The decimal point itself is read as the word and. That's the only time you ever say the word and in a number, is when there's a decimal point. And then you take whatever number comes after it, the whole line of decimals, and you would say that as 6, and then whatever place value the last digit is in, 6/10. This is how we read this decimal in words: 17 and 6/10. 17 and 6/10. So could you figure out what this big number over here would be read as? Can you figure out what that might be? Take a moment and try to figure that out. So that number would be read like this. Let me shrink you just a little bit. 1,208. That's how we say the first part. 1,208. That's our number in front of the decimal point. The decimal point itself is read as and then this over here, we have 925. There's a 0 in front of that, but we just would say 925. And then we would say the place value of that final digit on the right: tenths, hundredths, thousandths, 10,000ths. So this would be read as 1,208 and 925 10,000ths. In Blackboard, I have another link to GeoGebra, which gives you an opportunity to practice that. And so this is a drag and drop scenario where it will give you a number and it will give you a few different words, and your job is to drag it. So this is write the number 0.3 in words by dragging words into the box. This one would be read as 3. I'm holding my mouse button, and then tenths, and then you can check it. And it'll say yes, and then you can try a new problem. So if you're not completely confident on saying those numbers the right way, this is a good place for you to practice that skill. But just for a little practice right now, why don't we try doing several of these? The first one we will do is this, and I'm just going to use that word point, even though that's not the proper way to say it, but I'm going to say 3.472. And the other one I'll do is, I'm just going to write it. I guess I don't even have to say it. So let's try these two. Take a moment. See if you can figure out the right words. So again, we always start with the number in front. This would be read as 3. The decimal point is and then we look at the entire number after the decimal point and we say it as 472. And the last thing that we would note is the last digit's place value, and that is in the thousandths. So thousandths. And one other note, I mentioned this in a previous chapter, there is a hyphen between numbers 21 through 99, except for the multiples of 10. So 72 technically gets a hyphen in it. And then this next one, we have 16. 16, the decimal point is read as and. What comes after the decimal point? 14. And that is in the last digits in the hundredths place. Hundredths. So 16 and 14 hundredths. So that's how we would properly say those numbers. So just to kind of wrap up this first video, one common place that we have to do that and write numbers out is in a check. Now I know that we don't do lots of checks anymore. Occasionally you do, or you might receive them, but that written part here, right, is where we often see those numbers written out properly, right? And so this check was for $177.24. So we'd say 177 and 24 hundredths. Sometimes people will take that 24 hundredths and write it as a fraction instead of the written word. Either one of those would be okay. But it is important to note how that does work. So in the next video, we will start looking at how we model our decimal numbers.